Hello, welcome to the meetup number 53 for Beginners Python. Today we'll be looking at using plotly, which is a graphing package, and we'll be using that with some COVID-19 data to plot different data. So first of all, just like to check that you can hear me all right. If you could just respond in the chat on either Slack or in the YouTube chat if you can hear me okay. Okay, so I've started streaming. Try typing the URL in again. So yeah, I've started talking and streaming. So let me know if you can hear me from the chat. So it's saying I should have 4 concurrent viewers. And so I'm not getting any messages yet to say. I think Leo said he's seeing me okay. Can you hear me, Leo? All right, I'll start talking, and we'll start going through this. But send a chat if you're not hearing me. So I'll just say that. Okay. So today we're going to use plotly, and we're also going to look at, we're going to use pandas, data frames and series to prepare our data to be used by plotly. So plotly.py is the Python package that allows us to use the JavaScript plotly package, plotly.js. And the way it works is it assembles data that we've got into JSON links. And I'll just give Adeline the URL. So the tonight is going to be a more advanced session. The first week of the month will be next Tuesday. I've put down Wednesday is the meetup, but it should actually be Tuesday. So the next one is going to be Tuesday, the April the 7th, and that will be a absolute beginners one. All right. So I've given a link that has this Colab notebook, so you can get a copy of that and make a copy into your own Colab area, so you can save yourself a bit of typing. So make sure you do that and let me know if there is any problems in getting that. I'll just check. More volume please, a little soft, okay. Alright, I'll just turn the volume up. I'm trying to get rid of some of the white noise. So there we go, we'll go with some more volume there. Right, so let's, in order to use Plotly, we just need to import Plotly, but most people also import it as graph objects, as Geo, or they can import Plotly Express. So we'll look at the different ways you can use Plotly. My favourite is using plotly.graphObjects, but a lot of people like to use Plotly Express when they're using pandas data frames. So we'll import that. I'll select that cell and Shift Enter, and that'll import the libraries that we need. Now let's look at a simple example. What we're going to do is send a JSON object. Now a JSON object is a JavaScript object notation object to Plotly JavaScript, and they look very similar to Python dictionaries. So we can create a Python dictionary, and we can use this low-level routine to just send the dictionary straight to Plotly.js, and it will create the graph for us. So let's execute that by pressing Shift Enter. And so we can see we've created 2 lines on our scatter chart. We've got the X values here, and you see if we hover over them, we can see X and Y values for each point. So it's an interactive chart. We can do lots of things with it. There's a little menu up here that we can do things like we can zoom in. So I can now drag here and I'll just zoom in on the part that we've zoomed on, or we can reset back to our original axes. We can also turn particular lines off by clicking on them in the legend, and turn them back on by clicking on them again. So because we're using Colab, Plotly's worked out, and they've got some a renderer specifically for Colab to send it so that all the JavaScript works that can show our chart that we've constructed in Python. If you're not using Colab, you can also use, you can write the file out to an HTML file. So for example, if I look here to the left, and this might take you a little bit of time the first time you go in to connect, you can see just there we've just got a sample data file. And now if I run this cell, once again it creates the plotly.io.show figure, but it also writes an HTML file over into our files, and that'll come up soon. We'll just wait for that to come up to create some data, and there we can see figure1.html has now shown up. It's 3.14 megabytes, so that little dictionary there has created 3.14 megabytes of data. I can download that file as an HTML file, and that's an HTML file that's got all the JavaScript in it. And if I open it up, you can see it's just here in my downloads folder. It's just opening it up as a file, and it's got still all the same interactivity. So I can click on a legend to turn off a particular line. I'll show it again. Okay. So I've created here some data that we're going to show in our chart, so I'll just show you what that looks like for challenge 1. So our x's is just going from -10 up to +10, and our y's is just this function here, 1 over 1 plus the e to the minus x, which is, you'll all recognise that as the sigmoid function, and these are the values of that sigmoid function. Now I've used the numpy version of exp here, and that lets us run the function on an entire numpy array. So I want you to create a dictionary like this, and plotly.io.show that figure. So while you're doing that, I will respond to any questions that you've got in the chat. Okay, I'll turn the volume up a little bit. Now you say the resolution's gone bad. I think I'm still connecting at full resolution. I'll check on that. I'm not getting any errors on my YouTube Studio panel. Okay, I'll start working through this. So let's just copy and paste this, what we need to answer challenge 1. I'll just do that. So our x is just going to be the x that we've stored here. Our y is just going to be the y. The name, we'll just call it sigmoid. Now we've got, in our demo I had 2 lines, but we're only going to have 1, so I can get rid of one of those out of the list. And we'll just say that's the sigmoid function. Okay, and we'll show that. Don't need the comments. There we go, sigmoid function constructed as a dictionary. But we don't have our legend here. Now because there's only 1, by default it won't show a legend. So we have to put in that we want a legend. So we just have to know that the name for that is show legend true. So this is a problem with trying to create these as dictionaries. And there's our legend. And you can see there's the solution, which I had. Right, so Leo's asked, what? Resolution has gone bad. YouTube had autoed down my resolution. I have set it back to 480p. I've set the resolution at 720p, so I'm not sure why it's going at 480p. Just check. Yeah, saying 720p that I'm broadcasting at. You can only see the top left corner of the screen. All right, so if you select 720p, are you getting the full screen, or am I not showing the full screen? Because that is something it's hard for me to tell. I'll bring it in. Just trying to get more of this to show on the screen. Okay. I'll find it zoom. Why is this not showing? That's improving. Okay, we've got some improvement. So I can't make any changes while I'm streaming. Okay, I'll try to yes, I'm using multiple screens. I have it just switched to the other screen and it worked fine. Okay. Okay, he wants to click another one of those. Okay. All right, I think that's now showing the text, although I can't read it, but that's okay. So this is our sigmoid function that we've created. So let me know if that's okay now. All right. Yeah, so we've got, that's what we've done by just using a dictionary. We'll move on. There's the solution to that challenge. So we can go up to a high level, which means that we're letting the library do a bit more of the work for us. So we've just got to create this dictionary, but rather than just having to remember all these keys and values to put in, we'll start using the constructors that are provided by graph objects. Now remember, we imported plotly.graphObjects as GO, so we can say this constructor here, go.figure, and we provide in it the data and the layout. Now it doesn't look like it helps a lot, but if you are in there and you're as you're working, it can give you a list of all the parameters that you can provide for that constructor. So that helps us if we wanted to know show legend, how it's spelled. You'll find that most of these parameters don't have underscores in them. They'll just be the words joined together, and there's a reason for that later. So here we go. We're going to try to fit it inside the screen. Okay, so Arun's given me a clue, so let's see if I can do that. Of got to click the red border. Except I can't scroll. Ups. Okay, I'm trying to drag it, it's just not dragging. Okay. That's that. There's this other border. I've got two borders that I'm trying to sort out. I don't want to resize, so I'm not sure why that is. When I resize, they scale. Wish I could zoom in and out. I don't know. Ah, that's looking better. Okay, how's that? Is that any better? All right, I'm going to go with that. So once again, now we create a figure, and it's not just a dictionary, it's a full figure class. So we can, it's got extra methods, so the write HTML method is built into it, and the show method is built into that class. So we don't have to use plotly.io anymore. We can use write HTML, or we could use show. So let's have a look at this data that's created using graph objects. And this is a bar chart that we've created using graph objects. Once again, it's got a legend, so we can click on the legend, and that will hide or show the data, and we can zoom and pan with all the controls up here. So to have a look at what creating this class has done, we can print fig, and it shows us pretty much what the dictionary is that it's created. So it's done all the work of creating the dictionary. We just created the graph objects up here. So we created a go.bar that we put into data, into this list, and we did a go.layout that we put for the layout, and in the layout we put some title, so a go.layout.title. Now if you want to see the actual dictionary that got created, that's just a summary of it. You'll see under template here, it's only got ... because there's a lot of stuff in template. We can have a look at the full dictionary, and there it is. So that's all the stuff that's getting sent to plotly.js to construct that graph. So I'm just going to hide that because we don't need to know any of that. So challenge 2 is using the X and Y from challenge 1. Plot the values using graph objects. And ask me any questions while you're doing that. So we could go 10% wider. Let's try that. And I can even zoom in a bit. Yes, the trick I had was I didn't realize there were these two rectangles I had to align, and I didn't realize by clicking I would unselect one and select the other. So I couldn't just drag, I had to click and then drag. Okay, so let's have a go. We want to use the same as before, so we'll just copy and paste from here. So X we'll just use X equals X, Y equals Y, and we're going to do a scatter rather than a bar. And it's going to be called sigmoid. We don't need to write the figure 2. And that shows us the sigmoid constructed using graph objects. Now I've done in the solution to challenge 2, I've added a few extra things that you can put into here. So we can say, rather than just lines, we want lines and markers, and we can put what the marker symbol is going to be, and marker line width and marker size. So that's what we've created in our figure, but now it's going to create a dictionary, and check out what happens with marker symbol and marker line width and marker size in the dictionary. So I'm doing a print of fig. And we'll have a look at the dictionary first. So in the scatter, which is here, type equals scatter, it's created a marker which has then got a dictionary in which is a line, and in that dictionary it's a dictionary as well which has got a width. So this is a shorthand, marker line width, for saying marker is going to be a dictionary which is going to have a key of line, which is going to be a dictionary which has a key of width, and that's the value we're going to set to 1. So by using these, they call them magic underscores, you can define your dictionary. And that's a lot easier than constructing this raw dictionary that we would have had to do if we were using the original way. Okay, so we run that, and we see that there's the hash dot marker that we're using. What are the markers that are available? Now I love this example that they provide at plotly.com. They actually use, they create a graph themselves that shows all the different markers. So if I run that, this is just a plotly chart, and you can hover over any one of them and it'll tell you what the name is and what the code number is if you want to use any of these symbols in your charts. And that's the name circle, that's the name circle dash open, circle dash dot, circle dash open dash dot. Now Plotly Express is a high level API again designed for data exploration. So if we had a data frame with just some data in it, we can run Plotly Express, which we've imported as px, just to create a line, and we just use the column names in our data frame to say what our x and y are, and we can even group them. We can even create a legend. So this color means really create the legend or plot them in a different color for each of the ones. So anything in group is going to be plotted a different way. So we've got 3 of the are going to be in the up-down group and 3 of them are in the climber group. So let's have a look at how Plotly Express does that. I don't actually like Plotly Express so much. I can never find out what, because they've changed all the names of the parameters. So it doesn't matter that I know the name in a graph object, I don't know the name in Plotly Express. So this is our data frame. It's got 6 records in it. So you see the 3 that have got up, down, they've been all put in as one series, and the 3 that are in climber, that have got a group of climber, they've been put in the other. We can turn off, and it's still an interactive graph like before. So challenge 3 is to do the same thing using Plotly Express. And I'll look at any questions that have come up while you're working on that. No questions on Slack, and none in the chat. So the first person who finishes the challenge, if they could just say done in the chat, and then I'll just continue on from that. So some of the challenge in doing this is how to create your data frame, and there are different ways of creating the data frame. We've got the data in series. So we could, what do we got? We've got a Y and an X. So we could just say df equals pd.data frame. And the data, we could define it using the dictionary notation, for example. So we'll give it a column name sigmoid, and it will have all our Y values. And then we can say our index is X. Now, because we want a legend, we've got to create a whole column that's we can assign to color. So we'll create an extra column. I'll call it function equals sigmoid, and let's have a look at what our data frame looks like. And there we go, there's our X values in the index, our Y values in the column called sigmoid, and in function we've got the names sigmoid. And then once we've got that, we can plot that, which I'll just take this line here from the answer. And that's all I really need to do. I can say px.line, because px.line returns a figure. And in Google Colab, what gets returned from the last statement in the cell is what gets displayed. And the Colab renderer knows that this is a figure that has to be displayed using plotly.js, and so it will produce the graph for you. Now, if you're using something else other than Google Colab, then you should store that figure into a variable, and then you can do figure.show. But for Colab and Jupyter Notebooks, you could just do figure, which is what we effectively did above, or you could do figure.writeHTML if you were just using normal Python and you wanted to save the HTML file. So running the solution I've got there should give the same answer. Yep. In Plotly Express, they've got a few data sets in there if you want to play with data, and it's always laborious trying to create data frames. So they've got one in there called Gapminder. They've got other ones in there. If you look up the documentation, you'll see what they are. So this one, Gapminder, will give us this data here. So you can just look at that data frame if you want to have a look at it. Just play around with some data without having to laboriously create data frames. Okay, now we're going to use some data that Arun introduced us to the other day, which is the COVID-19 time series data. Since Arun introduced us to it, the URL has changed. So the ones we're looking at now have got this underscore global at the end. So you'll see that's a different URL to the one that we were using before. So let's have a look. You'll be familiar with it. No real index because we just did a read CSV. Province and state, sometimes it exists, sometimes it doesn't. And the country and region, there's always a country there. We've got a latitude and longitude, and then for each state we've got a count of, in this case we're looking at confirmed cases. But these column names are all just strings. So if I want to list all the states in alphabetical order, I can access the data frame using the column name province/state, and then I can find the unique list of those. So I'll just do that in a province state. So that'll give us all the province and states in the 253 records, and a lot of them just don't exist. If I do unique, I get the unique list, but I also get NAN for not a number as one of them. So I want to drop the NAs from that, so I can do drop NA, and then that's just got the list of them. Now unfortunately they're not in alphabetical order, so it's a bit hard to find something in there without having to read through the whole lot. So to sort it, I can store this into an array, and I call it array state, and then I can call the .sort method on that, and that'll sort it in place. So it's created a numpy ND array. Now they're all sorted. So print the type has printed that numpy ND array, and print the state has given me all the ones in that numpy array, and now they're in alphabetical order. Okay, so challenge 4, we'll just do a bit of practice with data frames and series, or actually data frames and numpy arrays. So if you want to do the same thing for countries, see what you come up with. That should be very quick, so the first person who just does it, just say done in the chat. Or if you think I'm going too fast, say too fast. Now it's a good idea to actually type this stuff in rather than just look at the answers, because you remember it a lot better. And try typing it in from memory rather than just following exactly what the solutions say. Even try to do something that's different to the solution. There's more than one solution to these, so if you can come up with a different solution, that's great as well. And maybe share it with everyone in the chat if you come up with a different solution. Okay, well it's pretty simple. We just find the unique list from there, store it in an numpy array, sort it, and then print it out. We don't need to do the drop NA this time because there were no NAs in that list. So we get all our countries. Now I'm just going to remind you a descending sort. Good question. So there's lots of different sorts. I haven't tried this one. kind order equals and here's an array. So it sorts the array in place, axis along which to sort. Okay, it tells us the sort of sort. That looks good. So some of those might be quicker for different sorts of data. So you just choose one depending on what data you've got. Order. Can be specified as a string, and not all fields can be specified. Order equals y. Yeah, I'm not sure how to specify the sort order. Equals 1. Y is an int. It could be that there's another no, sorry. So now we'll move on to filtering. So that's the filter, and that DF confirm country region. So if we were looking for Australia, that will give us a list of, it's like a series of trues and falses, depending on each row in that DF confirmed has a country of Australia. And then we can apply that array of trues and falses into DF confirmed, and that will just return those records. So let's have a look at what we get. We get these 8 records by filtering on Australia. We could also filter just on Queensland, or you can filter on a state and a country by putting parentheses around your filter and joining the 2 sets of filters with a single ampersand. And that should give the same because all the Queenslands were in Australia. Right, so now we want to define a function which takes 3 arguments. It's going to take a data frame argument, a country and a state, and we'll return a data frame filtered by the country, by the state, or by the country and state. So you'll see I've got a solution for you there, but you could try to come up with a different solution or even try to understand why my solution works. So feel free to ask questions. So I don't want to spend too much time teaching how to use a particular library, although pandas and numpy are libraries that you'll use a lot of the time. But plotly, I'll show you how to get a few things out of plotly, but you can find a lot of that stuff out yourself because it's got a huge range of charts. There's no way I'm going to cover all of them. So I'm trying to cover more the techniques that you would use to use plotly rather than all the range of things that plotly can give you. while you're working on that, I've just found a solution to sorting in reverse order. So let's go, we'll do it on the states. So you sort it first in ascending order, and then you reverse that, so I'll just call it array reverse state, and that's just AR state. So, well, we're just going to look at it, so I don't even need to store it. So that's using slicing on the numpy array. So we're starting from the beginning, we're finishing at the end, and we're stepping through in -1s, so backwards. And that gives us the reverse. Okay, so let's define a function, df for location. So it's going to have 3 parameters, country and state. Now, country and state are optional, so we'll give them default values. So if it's none, if country isn't none, then if we've got the state as well, we want to return the data frame filtered on state and country. So we'll have our, let's copy that. Okay, if we don't have the state, that means we must have just the country. So we just got the country. Okay, otherwise, if we don't have the country, then if we've got the state, we can return that, and we don't need the second one. Else on that, that means we haven't got the state or the country, so we'll just return the original data frame. Okay, so that's a different way to the other solution. We could check it works. Okay, this is New Zealand. Let's try state Queensland. country Queensland, so it didn't return anything. That's good. Got the right answer. State Queensland returns the 1. Okay, looks like it's working. And alternatively, you could use this solution. So I created a list of trues matching the number of rows, and then I just did an AND on that if there was a country, and an AND on that again if there was a state specified, and then ran that filter on DF to get the full answer, and that should also work. Okay, let's try running DF confirmed by location for Australia. So we use our function that we've created, and now we're going to total all the values in the columns. So we're going to go along the index axis, and so let's have a look at that. The type of total is going to be a series. We've used the data frame function sum along the index axis. So it's summed all the states together, Australian Capital Territory, New South Wales, blah, blah, blah. That'll have all the states summed using string concatenation. It's summed all the countries together, which is Australia, 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 Australia. It's summed all the lats together and the longs. None of that makes a lot of sense. The only thing we're really interested in is the totals for each of the dates for our confirmed by location. So we can slice off the first 4 rows, and we've noticed that we're actually dealing with a series here. So I've called my variable series sum so that I can remember that I'm working with a series. So let's see what that looks like. That looks better. I've just got dates and numbers. The index is currently strings, but we prefer date times. So we can use PD to date time to convert that index to date time. And let's see what we get. Yeah, so this is the index beforehand, it's all strings. This is the index after we make that change, and now as you can see it's called a date time index. So we converted it to date times, so then we can actually do some more interesting things on that. So challenge 6 is define a function which returns a series of values for a given data frame and country and or state, and we want the index for the return series to be a date time index. So you're going to write a function here. It's going to call the other function that we've already written, df for location. So have a go at that and ask me any questions in the chat. So I was doing a sort before on a numpy array. Leo's asking me how to sort a data frame. We could try, see if the series has got a sort method. Sort values. And that's got a field ascending, which is a Boolean, which defaults to true, so we can say false. Yes. There we go, that's sorted descending. But that's, so data frames and series, they come from the pandas library, but the arrays that we were looking at, they were used in numpy, so they come from the numpy library. So you can get differences between those two different libraries because they're written by different people. And that sort doesn't sort in place, so you'd have to add in place if you wanted it to save in place. Okay, let's hide some of these results so we can see. So I'll go through the solution for this. Series sum for location. So it's going to be pretty similar to our df by location. It's going to take the same parameters, Sandy, so I can just copy and paste that. Returns a series of values for a given data frame. So we want the data frame so we'll call the df for location. Yeah. Based on the passed in df, we'll have the country equals country and state equals state. Then we want to sum them along the index axis. So I can just df.sum axis equals index, which is probably the default, but I like to put it in. Then we can do the slicing straight away. And we want the index to be to date time, converted to date time. And then we'll return it. Okay. And then we can check if it works. I'll take this from the solution. Mine looks pretty close to the solution. I just used a different variable name. Yep, they look like pretty good figures. It should be the same if we run the solution. Yep. Okay, challenge 7, define a function location name. So this is more exercise in just creating Python functions. So we're going to use this later in a chart that we're going to produce, so we'll create it now so we don't have to keep retyping the code all the time. So have a go at that. There's a solution here, that's one solution, but you can see if you can come up with another. So I'll do one again based the same as I did last time. So we've got if country, if state, and we want to return we'll do the state first. So you can see there's different ways of solving the same problem. We'll just check. Queensland, Australia. Okay. And you can check all the other ways of doing it as well. Right, so for a reason that will become clear later on, we want to look at the series of totals of COVID cases that are greater than or equal to 100. So we can use a filter. We first of all call our function series sum for location based on our confirmed data frame to get the series sum, and then we filter that based on population number of cases greater than 100. We can see that on the 10th of March was probably the first time that we had cases greater than or equal to 100, and then 11th and 12th, so every time after that. We can put that into a data frame, and we've given the data frame a current number. So series sum. Okay, so we haven't, in this case, that's the full series sum without, because we didn't do this one, we haven't saved our filter, that's just what it looks like. So it's got the full data from the 22nd of January. And our challenge 8 is to find the date and the number of confirmed cases exceeded 100 and what the count was on that day. So it shows you how to do a filter there. Oh, so you need to find out what the number of cases is on that day. And then with the data frame, okay, so I'll do that. Any questions on that? I might just keep working on this. I'm not sure how long. I'm not getting any dones from people working through, so I'll just see what we've done. So the index start is we've got the series that's here. It's the index that we want to apply the filter to, not the values. So there's our filter, series sum greater than or equal to 100. We apply that to the index, so we get now we get an array of the index values, values, and we want the first one. So we use that array indexing in square brackets with number 0. So that'll give us the first index, which should be the 10th of March. and the value on that day, we put that index into the array for series sum, and that'll tell us what the array is. Now, we could have done the same thing with the data frame. It's a little bit more verbose, so it's probably easier just to do it on the series at this stage. And see what we get. We get the 10th of March, and there's 107. So we're going to only plot the values that are greater than 100. So we can use the dot lock on that df sum so that we've only got values greater than or equal to 100 in our plot. So the question here is write a function to plot those numbers after the starting count is reached, and for the advanced we want to plot the count on a logarithmic scale. Who wants to have a go at that one? Or do you want me to just work through the solution? So what I've done in this solution is all the lines that we've used up ahead, I've put them into a function. So our function is going to take these parameters. Okay, so Peter said some of it makes sense. So which bits are not making sense? All right, well, I'll explain the solution. Maybe it's part of the solution that's not making sense to Peter. So we call our function series sum for location to get the total number of confirmed cases for that location and store them in series sum. We then look for where it's greater than or equal to 100 and find the first one. So that gives us our start index, which will be the 10th of March for Australia. We put it into a data frame, and then we slice the data frame just from the 10th of March onwards. We get a location name. We'll just store it in a variable called location, so it'll look nice on our chart. So we can create a scatter chart. We'll use date versus current numbers, and we'll show the we'll draw it as lines rather than markers. And in the layout, we'll just put a title at the top, confirmed cases. So we've got a description here. That's where someone's going to type in the word confirmed, as we have here, so that we can put that on the graph, starting from 100. So let's have a look at what that looks like. Oh, and I've updated the y-axis to show it in a log rather than linear type. So you can choose log there or linear. So that's a log curve for everywhere, and I think you'll find that a lot of that is because China did the lockdown here, so it made a flat curve. So let's have a look at what that looks like in a linear curve. So that's the exponential that we're used to. So logs make it possible to actually do analysis on these things, so we're going to use logs. All right. So the next, now we're getting into some real mathematics here, is how to calculate the average doubling rate over the last 3 days. So what we need to do is we need to know what the number of counts of confirmed cases is today. And we also need to know what it was 3 days ago. And then we're going to do a sum on that. to work out how many days it's taking to double. So once again, we find out when the series sum is greater than 0. We'll do, we'll put that into a data frame. We'll have a previous column, we'll create a previous column based on the current column, but shifted that number of days. So let's have a look at what that looks like. So this is Australian data, that's what we were using in series sum. So the current value is 107 on the 10th of March, and 3 days ago it was 63. And you can see here on the 13th of March the current value is 200, but the previous value is 107, which matches that one. So now we've got, for each date, we've got the current value and what it was 3 days ago. So that uses that shift and average days to work that out. Now we want to use this formula here to calculate how many days it takes to double. So it's the average days, which is 3, divided by the log to base 2 of the current value divided by the previous value. And that'll tell us how many days we're averaging. Now the Australian government says if we can get to 6 days, then our health system can cope. If we're doubling quicker than 6 days, then we're in trouble. Now we want to use this log to base 2 over a whole array of data, so we can't just use the normal log 2 that comes in the math library. So we have to use we can use log 2 that comes in the numpy library, because that'll work on whole arrays of data. Except that it doesn't work on arrays of integers, it only works on arrays of floating point numbers. So you have to convert the current values here and the previous values into floating point numbers so that we can run a logarithm on them. So we just take float current is just going to be current but as type float, and float previous is going to be the current shifted and then saved as type float. Or we could have done the shifting just on float current, that would work as well. And then the doubling days, we can just do it, rather than having to loop through, iterate through every row in our data frame, we can do it in a single statement and it will do it for us for every row in the data frame. So let's have a look at what that looks like. We've got our date index, we've got our current number of confirmed cases, our previous number of confirmed cases converted to floating point, and the number of doubling days. So it started off 3.9, 6.09, that looks good. And we're currently up to 6.3, so it looks like we might make the six days for doubling, which means our health system may be able to cope. So challenge 10, plot the days to double. So we've got the data in here, in this doubling days, and in advanced is plot at the same time as count using the using plotly subplots. Okay, Peter's saying he's trying to keep up with the syntax. That is true. It's hard to remember all these new syntaxes. Even I have trouble remembering them all. So I'm trying to tell you the things that I've discovered about doing this that are going to be a problem. But once you start doing some of this stuff as real problems, you'll see where the issues are going to come up. So try that and give me send me a chat if there's any you got any questions on that. So I'll show you how to plot the days to double. Maybe I'll show you how to do it and then later you can have a go at it doing it yourself and see if you can do that. So I'm going to create this function, which is plot doubling for location. So let's define that. Now, we've got to get our data. So let's have a look at how we got the data before. I'll just close these up. So it's going to be pretty similar to what we did in challenge 9. We're going to, do we want to just start from greater than 100? Yeah, we'll start from greater than 100 because we're going to plot them on the same chart eventually. Okay, so these lines will all be the same, so let's copy all of them. Yeah, we'll do that. So the index start's going to be the same, the sum's going to be the same. We're going to plot it, and then we're going to create these extra fields in our plot. Okay. All right, so see this line here, df plot is dfsum.log index start. I'll try it first without the copy, and we'll see what happens, and then we'll see if we need to put dot copy in there. So we've just sliced dfsum, and then we're just doing these calculations. Okay, and then we're going to plot the days to double. So we're doing a scatter plot, and we're just going to do doubling days. We're updating to linear, we don't need to do that, it's linear by default. Df plot, and so this is just days to double. I'll just call it. Okay, and let's try plot doubling for location. Give them the confirmed cases. Country equals Australia. And description equals confirmed. And that will use the default average days. Alright, now when we run this, we get these warnings here. Setting with copy warning. The value is trying to be set on a copy of a slice from a data frame. Equals value instead. So it gives us all this, and what that means is these things can be pointing to the same parts in memory, and if we make changes here, it can be affecting other data, which we don't want to do. So what we'll do is we'll make a copy. It's like what I've described in the past when you use tuples or lists. When you change a list, you can change other references to that list, but you can't change a tuple, so you don't have that problem. But this dfsum is a mutable thing, obviously, so by making changes to it, to dfplot, we can be accidentally making changes to dfsum. So we'll take a copy of dfsum in dfplot so that anything that we do won't affect it. There we go, that got rid of all those warnings just by putting .copy there. And we can see up here that we're up to 6.34 doubling days, and that's averaged over 3 days, so that's pretty good going. That should be pretty similar to what we had here. Oh, I put a better title on this one. Days to double averaged over last days. Higher is better, because it's not obvious that higher is better. So I like to put that in the title, which is there. Okay, so this is the advanced solution for challenge 10, and I'll quickly go through that. We want to show two charts on the same, using the same x-axis, so we can create these subplots. And I want the top plot to be larger than the bottom plot. Why don't I just run it so you can see what the outcome's going to be. Okay, so we've got these two charts. We've got a log scale up here. We've got linear scale here. This one shows the days to double, averaged over the last 3 days. This one shows the current number of cases, and it's pretty close to a straight line. I mean, if this one down here was all the same value, then that one up there on a log scale would be a straight line. You can see it's starting to curve down up here, because this one's going up here. They've got the same, they're using the same date range. March 11th here is March 11th there. Just ignore this every 6 days for the moment. So how did we create that? And you see the top chart is twice as high as the bottom one. So I created these make subplots, and I divided it up into 3 rows. And I said the first one is going to span 2 of the rows. Then there's going to be nothing on the second row, because the first one is taking that over. And then the last one will be just spanning the 1 row. I've put different titles on each one. The first one's going to be titled Confirmed Cases on a Logarithmic Scale, and the second one is Days to Double Average over the last so many days. Then I've put a title on the whole layout, and I've given a height to the whole layout. So it was a bit squashed vertically if I didn't put that height on, so I've added a height of 600. And then I've added the lines that I want. So the first one is a scatter using the current data, and I've put that in row 1, column 1. So that's row 1 up here in my subplots. And the second one, I want to put it on row 3 for the doubling days. Then I update the y-axis to say, I gave it actually a title for its y-axis, and I want it to be shown in log. Now the extra information I've put on here is I've put a line on it showing what it looked like if I doubled every 6 days. And that shows that if we were doubling every 6 days starting from 100, we'd now be at 1,078, but instead we're at 4,361. So we're doubling a bit too fast, but it looks like we're catching up, because the slope there is similar to the slope here. So the next challenge is add lines on the log chart for doubling every 2, 3, 4 and 5 days. And that'll be the last challenge for the night. Leo's asked, running many times gobbles up memory space. Does it handle memory time? So if you've got a variable and you assign it and you assign a value to that variable, then it will be using up memory. If you then replace the value in that variable with a new value, it will discard the old data that you've got there, and that's called garbage collection, and only store the new value. So that's how memory gets handled, so that it doesn't keep using up memory space. The garbage collection is a thing that goes through all the memory and finds if there's any variables currently looking at it, and if there aren't, then it clears it out so that it frees up that memory. So is anyone having a go at challenge 11? or does it look too hard? It's not really that hard, but you have to understand the solution to the advanced solution to challenge 10. All right, I've got no takers for challenge 11, so I'll do it myself. So I'll take this solution for challenge 10. So that's pretty much got everything in it we want. I'll even take the, see if it works bit. Okay, plot for location. Everything's there. And then right down the bottom, these lines here are calculating the straight lines for doubling days. And we've just got one there for doubling every 6 days. So all we need to do is repeat that for 2, 3, 4 and 5 days. So I'm just going to select those lines of code, press the tab, and that's now indented those. And we'll just say for doubler in 2, 3, 4, 5, 6. And that'll add another trace for each of those ones, and it'll even put them in the legend. So let's see what that looks like. Yep, I should put a colon at the end. There we go. So we've now got lines for every 2 days, 3 days, 4 days, 5 days and 6 days. I can actually turn some of them off. Don't really need the 2-day one. So I can see we've been going between 3 and 4 days, but the slope is coming down at the end. So it looks like it's matching the 6 days. So if we started at a higher value, say we started at 1549, let's try 1500. I don't put a comma before it. So what have I done here? Confirmed cases starting from 1500, 128. Didn't start from 1500. So I've got a problem in my, oh here we go, there's a problem in my code. So we want to start from there. There we go, so now when we look along the line, we can see 28100, and down here it would have been about 1500, 1682. And you see we're much closer to the 5 and 6 day lines. Okay, and there's my solution, which of course is wrong here. I've got to change this number 100 to numstart. So that was covering quite a lot tonight. So the next week is going to be an absolute beginners session because it's the first week of the month. So I guess I'll probably be doing that one. And then we'll have 2 weeks from Arun, and then I'll come back. And I was going to do another session similar to this one. It'll be using Dash, which is also put out by the Plotly people. And Dash allows us to create interactive web pages that show this data. Yes, so that'll be using the graphs that we've produced tonight and putting them on a web page, and also providing some controls so that any user can go to the web page that we've created and customize the graph to their own requirements, like changing the number to start from, changing which country is being displayed, changing whether it's showing a linear curve or a log curve. So are there any more questions for tonight? No, I just show that last one we've done, an average days equals 5, so that's just another way of doing it. Okay, well I'll stop the YouTube live, but I'll keep listening on the chat for 5 more minutes in case there's any questions there.